Implementation of the Sierpinski Triangle with Pic Microcontroller. Abstract. The objective of this paper is demonstrative and educational since it proposes the implementation of the Sierpinski Triangle fractal in a development system with the PIC 18F45K22 microcontroller and GLCD screen. The Sierpinski Triangle algorithm is simple and easy to implement and can be proposed as a didactic programming practice for students of the technological high school studying a technical degree in programming and computer science. Plotting times between 1.2 minutes and 4 minutes were obtained by varying the different settings in the internal oscillator of the microcontroller as well as by varying the number of iterations within the algorithm. Keywords: fractal, microcontroller, recursive algorithm, school math speech, development system. Introduction. A fractal is a geometric object in which the same pattern is repeated at different scales. In other words, a fractal is an object that shows self-similarity, on all scales. The term was proposed by Benoit Mandelbrot in 1977. Among the best-known nonlinear fractals are the Julia and Mandelbrot sets, which are obtained from the behavior of complex numbers when they are iterated by a function. Julia sets are obtained from quadratic functions too. Where is a complex number? The Julia set obtained from 1 is denoted. The process to obtain this Julia set from is as follows: any complex number z is chosen and a sequence of numbers is built iterating as follows. These fractals are the Cantor set, the von Koch curve and the Sierpinski triangle 3. For more details, the fractals see 4. Among the applications that fractals have is in image compression. This technique consists of compressing images using the fact of self-similarity at different scales of the same figure. One of the fundamental differences of this type of technique is that the compression code does not save pixels, so it is free of scales. Thus, it can be decompressed at any scale without having resolution problems. 5. To graph a fractal, it is required to program the recursive algorithms in programming languages such as C6, Visual Basic 7, MATLAB 8, among others. This paper is organized as follows. In Section 2, we introduce the basic concept Sierpinski Triangle. Section 3, present basics of microcontroller PIC. Implementation and simulations are provided in Section 4. Finally, a concluding remark is given in Section V. Some basics concept Sierpinski Triangle. Initially you start from an equilateral triangle. First, it must be divided into 4 internal equilateral triangles by joining the midpoints of the sides, eliminating the central triangle. For each of the triangles obtained, 4 triangles must be generated again by joining the midpoints and once again eliminating the central triangle. The process is repeated indefinitely. Figure 1 shows the procedure. 2. The Mandelbrot set denoted by M is defined by the set of parameters C4, 1, connected. The Mandelbrot set is obtained by modifying Julia's iterative process in 2, by making the point variable and setting the point 0 equals 0 in 1. This set is contained in a circle of radius 2 in the complex plane of the numbers 2. Linear fractals are constructed from a change of scale with elementary figures such triangles and squares. Examples of Figure 1. Construction of the Sierpinski triangle. Thus, the Sierpinski triangle is built by several triangles where each of them is made up of segments that join the midpoints of each side. To build the triangle on a Cartesian plane, we start by defining the vertices of the first triangle, and it is done as follows. Define 3 points with coordinates, A, X, I, B, Bx, by, and C, Cx, Psi. These will become the corners of the outer triangle. We mark 3 points 1, 2, 3 in each of the vertices to identify them. Define a starting point P, Px, pi, for example Px equals x and pi equals I. This can be in one of the vertices. In this way we will remain halfway between the selected point and the initial starting point. Now change the coordinates of point P, depending on the number you have taken. The point at which we have chosen is selected randomly by rolling a dice or using a random function and with the following rules. If 1 or 2 comes out, we go to point 1, if it comes out 3 or 4, we go to point 2, and if it comes out 5 or 6, we go to point 3. If you rolled 0, P equals, P plus A, slash 2. If you rolled 1, P equals, P plus B, slash 2. If you rolled 2, P equals, P plus C, slash 2. Performance available using PLL. No external components required, 4 crystal modes up to 64 MHz, 7 timers, etc. For numerical simulation and discussion, the school mathematical discourse, DME in Spanish, is identified because it is everything that remains unchanged in the classroom. It does not modify what is being taught but how it is being taught. 16. To avoid DME, the Sierpinski Triangle algorithm implementation was implemented in the Easy Pic V7 connectivity development system using a graphical liquid crystal display, GLCD, of 128 x 64 pixels. Figure 2 shows the development system employed in this work. The algorithm formulas, 2, were programmed in language using the Micro-C compiler of Microelectronica 13. 3. Go back to step 2, there place the point in the new position of P, and so on. In recent years it has been proposed to introduce the basic concepts of fractal geometry, including the Sierpinski triangle, in high school in order to recognize numerical and geometric patterns. 9. In the same way, it has been proposed as an academic activity in secondary education. 10. Likewise, at these levels the use of GeoGebra has been used to clarify its characteristics in an interactive way. 11. And to ensure that students obtain significant knowledge. 12. 3 Microcontroller PIC. A PIC is a programmable integrated circuit that contains the architecture to perform different tasks, which is why it is called a microcontroller. In order to classify the PICs, they are put into 3 families according to their capacity. These families are 8 bits, 16 bits, and 32 bits. These in turn have subdivisions which are already by the ranges of microcontrollers that we can use. The PIC 18F family offers many advantages in its performance. They offer numerous advantages, such as low-cost efficient solutions for general-purpose applications written in C that use a real-time operating system, RTOS, and require a complex communication protocol stack such as CAN, USB, among others. PIC 18F devices provide flash program memory in size from 8 to 128 KB and data memory from 256 to 4 KB, at speeds from DC to 64 MHz. 13. For example, some characteristics of the PIC 18F 45KK2R14, 1024 bytes data EEPROM, 64 KB linear program memory addressing, 3896 bytes linear data memory addressing, precision 16 MHz internal oscillator block width, factory calibrated to a plus or minus 1%, selectable frequencies of 31.5 kHz, 250 kHz, 500 kHz, 1 MHz, 2 MHz, 4 MHz, 8 MHz, and 16 MHz, 64 MHz. Figure 2. Microelectronica Easy Pic V7 development system. To implement, 3, the resolution of the GLCD has been considered. For the lower left vertex we consider the coordinate 0, 64, for the second, 64, 0, and for the lower right, 128, 64. The configuration for the PIC was to select the internal oscillator with the PLL enabled at 64 MHz. A function was included in the program to indicate with sound at 800 Hz and 2000 milliseconds the end of the routine. The program used is presented in the appendix and the execution time was approximately 1 minute. The random selection for each of the vertices was through the rand command, and dividing by 10,000. The modf command was employed to obtain its whole number component to obtain the numbers 1, 2, and 3 in the if statement. It is important to note that the functions rand and modf are contained in a set standard ANSI C library functions. The number of iterations used was 200,000. In figure 3 we show an implementation of the Sierpinski triangle by means of a right rectangle. For this, the upper vertex has the coordinate, 128, 0, in GLCD. Figure 3. Variant right triangle used in the simulation. Figure 4 shows the classic simulation figure of the Sierpinski equilateral triangle in the GLCD. The coordinate of the top vertex is 64, 0. Figure 4. Sierpinski Triangle. Years before, the Mandelbrot set has been programmed in Borland C6, Visual Basic 7, Java 17, among others. We can program the Mandelbrot set algorithm in Micro C to obtain the graph in the GLCD, as seen in figure 5. The Mandelbrot set is built iterating, 2. v1. Concluding remarks. In this work, as an example, the implementation of the Sierpinski triangle algorithm was presented in a system based on the Pic 18F45K22 microcontroller. It is possible to implement other fractals such as Bransley's Fern, and Julia sets, among others. However, it is possible to optimize the procedures using fixed point in programming 18, a random function declared by the user 19 with some probability distribution 20. In this paper we chose to implement the Sierpinski triangle algorithm because it is easy to implement since the formulas are arithmetic for basic programming class and it is illustrative for students who are beginning to program using iterative and conditional statements. We hope that students will be interested in the study of science and engineering. Acknowledgements. Authors would like to thank Roberto Ruiz Gomez for his contribution to this project. The authors are grateful to the anonymous referee for a careful checking of details and helpful comments that improved this paper.